Hello there, and welcome to Sealed, the quiet corner of the night, where curiosity settles softly, and the universe is allowed to lean a little closer. Everything sealed has a reason, and tonight, the thing that has been sealed away is older than almost anything you could name, older than this planet, older than the sun, older than the first grain of dust that would one day become a world. Tonight, we are going back, not a little way, not a few centuries or a few million years, but almost to the very beginning, to a time when the universe was young and dark and utterly without light. We are going to find the first stars that ever shone. Before we begin, let yourself grow comfortable. Loosen your shoulders. Let the weight settle out of your hands. Let your breathing slow, the way it does when there is nothing left that needs doing and nowhere else you need to be. Wherever you are listening from tonight, whatever hour it is where you are, know that the story we are telling has been waiting patiently for more than 13 billion years. It is in no hurry, and neither are you. If this gentle kind of wondering is the sort of thing that helps you drift, I would be quietly grateful if you would like this video or subscribe to Sealed so that this soft little corner of the cosmos can find others who might also need a peaceful place to rest. Now let your thoughts loosen and follow me backward, past the stars you know, past the galaxies, past the light itself, into the long darkness that came before dawn. Because there was a dawn. That is the first strange and beautiful thing to hold on to. The universe we live in, so full of light that on a clear night the sky seems crowded with it, was not always this way. There was a time, an immensely long time, when there were no stars at all. No suns, no points of brightness anywhere. The whole of creation was dark, and it stayed dark, and nothing in it had ever burned. And then, somewhere in that darkness, the very first star flickered into being, and the universe changed forever. That moment, that first light, is where we are going tonight. But to understand it, to really feel the weight of it, we have to begin in the dark. We have to begin before the beginning of light. Let us start with the beginning we think we know. Around 13.8 billion years ago, everything that exists, every particle, every scrap of energy, every possibility that would one day become a galaxy or a mountain or a living thing, was gathered together in a state so hot and so dense that our ordinary words begin to fail. There were no atoms yet. There was no space in the way you picture space. No comfortable emptiness through which things could travel. There was only a searing, seething ocean of energy, expanding, cooling, unfolding. We call the beginning of this unfolding the Big Bang, though it was not really a bang, and not really in any one place, because every place was inside it. It happened everywhere at once. It happened here, where you are lying now, and it happened at the far edge of the most distant galaxy. And in that first instant, those 2 points were pressed together, closer than you can imagine. In the earliest moments, the universe was a fog of pure energy, so hot that light itself could not travel freely. Particles formed and dissolved, in a churning that lasted only fractions of a second, but shaped everything that followed. As the universe expanded, it cooled, the way a breath cools as it spreads into a cold room. And as it cooled, the first simple building blocks settled out of the chaos. Protons, neutrons, electrons, the raw material of matter, scattered thinly through a growing darkness. For a while, though, even these simple pieces could not come together into anything stable. The universe was still too hot, still too crowded with energy. Every time a proton tried to capture an electron, to settle into a calm partnership and become an atom, a passing burst of light would knock them apart again. Imagine trying to build something delicate in the middle of a storm, only to have it torn from your hands the instant it takes shape. That is what those first minutes and hours were like. Matter existed, but it could not rest. And because light could not pass freely through this hot, charged fog, the universe in this era was not transparent. It was opaque, glowing, like the inside of a cloud lit from within. If you could somehow have stood there, you would have seen no distance at all, only a blinding, featureless brightness pressing in from every side. This lasted, remarkably, for around 380,000 years. That is a long time by human measure, longer than our whole species has existed, and yet, in the life of the universe, it was only the very first breath. And then, at last, the universe cooled enough. It dropped below a certain temperature, a threshold, a quiet line crossed in the dark, and below that line, something gentle and enormous happened. The protons and electrons could finally come together without being torn apart. They joined, they settled, they became the first true atoms, mostly hydrogen, the simplest atom of all, a single proton with a single electron circling it, some helium, a little heavier, and almost nothing else, just those two, hydrogen and helium, filling the whole of the young universe like a vast and silent breath. Scientists call this moment recombination, though it is a strange name, because the particles had never been combined before, and with it came one of the most important events in the history of everything, an event with a name that sounds almost like poetry. The universe became transparent. For the first time, light could travel freely. All that trapped brightness, all that glowing energy that had been bouncing endlessly between charged particles, was suddenly set loose. It streamed outward in every direction, unhindered, free at last to cross the growing dark. That released light is still traveling, even now. It has been traveling for 13 billion years, stretched and cooled by the expansion of the universe until it is no longer visible, no longer warm, only a faint whisper of microwaves that fills all of space. We call it the cosmic microwave background, and it is the oldest light we can ever see. It is the afterglow of that first great clearing, the moment the fog lifted. When you look at it, you are looking at the universe as it was when it was younger than a single human lifetime is to us now. A baby picture of everything, taken before there were any stars to be in it. And here is the part that is easy to miss, the part that gives tonight its shape. When that ancient light streamed away, it left the universe behind in darkness, because now the universe was clear, and quiet, and cold, and full of nothing but thin hydrogen and helium gas drifting in the black. There were no stars yet to make new light. The old light was leaving, and so the universe entered a long, deep night, a period astronomers call, quite fittingly, the cosmic dark ages. Sit with that for a moment. There was an age of the universe that was genuinely, completely dark. Not dark like a night on Earth, where there are stars overhead and a moon and the distant glow of cities. Truly dark. A universe with no source of light at all, expanding silently. A vast ocean of invisible gas cooling in a blackness that had no edges and no end. If you could have opened your eyes there, you would have seen nothing, no matter how long you waited, no matter which way you turned. There was simply nothing shining. The darkness was total, and it was patient, and it lasted for a very, very long time. This is the sealed chapter of the universe's story, the part we can least easily reach. We cannot see into the dark ages directly, because there was no light coming from them to see. It is a gap in the record, a hidden stretch of time between the old afterglow and the first true dawn, and it is precisely in that gap, somewhere in that immense unlit patience, that the first stars were quietly, slowly, being prepared. Not yet born, but coming. The darkness was not empty. It was pregnant with light that had not yet learned how to shine. Let us stay a while in that darkness, because it is more interesting than it sounds. It was not perfectly smooth. That is the crucial thing. If the young universe had been perfectly even, perfectly uniform, with its hydrogen and helium spread out in exactly equal thinness everywhere, then nothing would ever have happened. Gas would have drifted forever, cooling and thinning, and no star would have formed, and no galaxy, and no world, and no you. A perfectly smooth universe is a dead universe, but ours was not perfectly smooth. It carried within it, from its very first instance, the faintest of ripples, tiny variations, places where the gas was a whisper denser than the average, and places where it was a whisper thinner. We can actually see these ripples, imprinted on that oldest light, the cosmic microwave background. When astronomers map it, they find it is not perfectly uniform. It has patches very slightly warmer and very slightly cooler, differences of only 100,000th of a degree, so faint they took decades to detect. But those minuscule differences are the seeds of everything. Every galaxy that has ever formed, every cluster of galaxies, every great structure of the cosmos, grew from those tiny ripples in the primordial dark. They are the fingerprints of creation, pressed into the first light and carried forward through all the ages since. And in the Dark Ages, those ripples began to matter enormously because of the quietest and most patient force in the universe: gravity. Gravity does not rush. It does not announce itself. It simply pulls, gently and endlessly, drawing matter toward matter, again and again, for as long as there is time. And there was a great deal of time. In the regions where the gas was very slightly denser, gravity had very slightly more to pull on. So those regions pulled in a little more gas from around them, and that made them denser still. And being denser still, they pulled harder. And so, over millions of years, in the total darkness, the faintest ripples slowly deepened into real gatherings. The thin gas began, ever so slowly, to clump. But it was not only the hydrogen and helium that felt this pull. And here we come to one of the strangest characters in the whole story, a presence we still do not fully understand. Because most of the matter in the universe, then and now, is not the ordinary kind. It is not made of the protons and electrons and atoms you and I are made of. It is something else, something invisible, something we call dark matter. We cannot see it. It gives off no light and blocks no light. It passes through ordinary matter and through you, almost without a trace. And yet it is there, 5 or 6 times more abundant than all the ordinary matter combined, and it has mass, and so it has gravity. It was dark matter, in fact, that did much of the early work. Long before the ordinary gas could gather itself, the dark matter had already begun to collect into vast, invisible clumps, drawn together by those primordial ripples. Astronomers call these clumps halos, and you can picture them, if it helps, as enormous unseen valleys in the fabric of space, deep wells of gravity spread across the Dark Ages universe. They were not made of anything you could touch. They gave off no glow, but they were real, and they were deep, and into them the ordinary hydrogen and helium gas began, at last, to fall. The dark matter had dug the basins. Now the gas came flowing down to fill them. This is a gentle image to rest with. Imagine a landscape you cannot see, a terrain of invisible hills and hollows spread through the blackness. And imagine a thin fog settling over that landscape, drifting always downhill, pooling in the low places. That is what happened in the Dark Ages, across scales so vast that the numbers lose their meaning. The invisible halos of dark matter pulled the visible gas down into their centers, and where the gas pooled deepest, it grew denser and warmer and heavier and more crowded, slowly, always slowly. For the Dark Ages were long, and gravity is patient, and nothing here happened in a hurry. As the gas fell inward and gathered, it began to heat up, the way anything does when it is compressed, when it is squeezed into a smaller space. You have felt a version of this yourself, in the warmth of a bicycle pump forced down hard, or the heat that rises from a crowd pressed close together. The gas at the centers of these halos was being pressed by the weight of all the gas around it, and pressing makes heat. But heat is a problem, in a way, for the making of stars, because hot gas pushes outward. Hot gas resists being squeezed. If the gas simply heated up and stayed hot, it would puff itself back out and refuse to collapse any further, and no star would ever form. For a star to be born, the gas has to find a way to let go of its heat. It has to cool. It has to shed its warmth into the surrounding dark, so that gravity can keep pulling it tighter. And here the first stars faced a difficulty that later stars would never know, a difficulty born of the poverty of the early universe. Because to cool efficiently, gas usually relies on heavier elements: carbon, oxygen, nitrogen, all the atoms more complex than hydrogen and helium. These heavier atoms are wonderfully good at radiating heat away, at taking the warmth of a collapsing cloud and carrying it off into space as light, allowing the cloud to keep shrinking. But in the Dark Ages, none of those elements existed yet. There was no carbon, no oxygen, no iron, no silicon, no gold. There was only hydrogen and helium, the two simplest atoms, and a mere trace of lithium, and that was all. The universe had not yet learned how to make anything heavier, because the only place heavier elements can be forged is inside stars, and there were no stars. So the first stars had to be born from the purest and simplest material imaginable, gas of hydrogen and helium alone, gas that was very poor at cooling, gas that resisted collapse in a way that later, richer gas would not. This is one of the reasons the first stars took so long to appear, and one of the reasons they turned out so strange. The pristine gas could only cool through a slow and awkward process involving hydrogen molecules, pairs of hydrogen atoms briefly bound together, which could shed small amounts of heat as they tumbled and collided. It was inefficient, it was gentle, it was the only tool the early universe had, and with that one clumsy tool, in the darkness, the gas at the center of a dark matter halo slowly began to cool, and to fall, and to gather toward a single point. We do not know exactly when the first star ignited. The Dark Ages are hidden from us, sealed behind their own lightlessness, and we can only model what happened there with our physics and our patient calculations. But most astronomers believe that somewhere between 100 million and 250 million years after the beginning, in the deepest part of one of those invisible gravity wells, in a cloud of the purest primordial gas, the collapse finally reached its climax. The gas at the very center grew so dense, so squeezed, so unbearably compressed, that its core temperature climbed past a threshold no gas in the universe had ever crossed before. It reached millions of degrees, and at that temperature, something new and self-sustaining began. The hydrogen nuclei at the heart of the cloud were pressed so hard together that they began to fuse. Nuclear fusion, the joining of light atomic nuclei into heavier ones, releasing a flood of energy in the process. It is the engine that powers every star that has ever existed, including our own sun, which is fusing hydrogen into helium at this very moment, and has been for 4.5 billion years, and will go on doing for billions more. But in that first collapsing cloud, in the Dark Ages, fusion had never happened in this way before. It was the very first time in the history of the universe that this particular fire had been lit, and when it caught, when the core ignited and began to pour out energy, that energy pushed back against the crushing weight of gravity, and the collapse halted, and the cloud steadied itself, and a star was born. Picture it, if you can, though no human eye ever saw it and none ever will. In a universe that had been dark since the fog first lifted, dark for 100 million years and more, in the black heart of an invisible halo, a single point suddenly began to shine. Faint at first, then steadying, then blazing. The very first star, the first light the universe had made for itself since the beginning. After the long night, a dawn, not of a whole sky, but of a single point, one small sun burning in an ocean of black, and around it, for the first time, the darkness had somewhere to retreat to. Shadows, in a sense, existed for the first time, because for the first time, there was light to cast them. We give these first stars a name, a rather technical and unlovely one, but it carries its own quiet meaning once you understand it. We call them population 3 stars. It sounds like they should be the third to come along, but in fact, they were the first. The naming is backwards for a historical reason. When astronomers first began classifying stars, they knew of 2 populations. Population 1, the younger stars like our sun, rich in heavy elements. Population 2, the older stars, poorer in heavy elements, found in the ancient parts of galaxies. And then, as they reasoned further back, they realized there must have been a still earlier generation, one made from gas with no heavy elements at all, gas of pure hydrogen and helium, a generation before the oldest they had ever seen. And rather than renumber everything, They simply called this earliest generation population 3. So the first stars carry the highest number, a small accident of history that hides the fact that they came before all the rest. What were they like, these first stars? This is where the story grows even more remarkable, because the first stars were not like the gentle, ordinary suns that fill the sky tonight. They were extreme. They were, in almost every way, giants and monsters, unlike anything that has formed since. And the reason lies, once again, in that simple, pristine gas, that hydrogen and helium with no heavier elements to help it cool. Because the primordial gas cooled so poorly, it could not fragment easily into many small clumps. When gas cools well, a collapsing cloud tends to break apart into pieces, and each piece becomes a separate star, and you get a scattering of many modest suns, some large, many small, most of them smaller than our own. That is how stars form today. But the first clouds, unable to cool efficiently, resisted fragmenting. They stayed whole. They gathered enormous amounts of gas into a single collapsing center, and so the first stars, when they finally ignited, were vast, not merely large, truly, extraordinarily massive. Where our sun holds a certain amount of matter, the first stars may have held tens of times that, or 100 times, or in some estimates even a few hundred times the mass of the sun, gathered into a single blazing body. And a star's mass shapes everything about it. It shapes how hot it burns, how bright it shines, what color it glows, and how long it lives. The more massive a star, the more fiercely it must burn to hold itself up against its own tremendous gravity. And so these first stars burned with a violence that is difficult to imagine. They were staggeringly luminous, millions of times brighter than the sun, so bright that a single one of them could outshine a small galaxy. Their surfaces were not the warm yellow of our sun, nor even the orange of gentler stars. They were searingly hot, tens of thousands of degrees at the surface, and so they glowed a fierce blue-white and poured out not only visible light, but great floods of ultraviolet radiation, the harsh, energetic light that the young universe had never known. And they burned through their fuel with terrible speed. This is the paradox of the massive stars, then and now. The more massive a star, the more fuel it has, and yet the shorter its life, because it consumes that fuel so extravagantly, so wastefully fast. Our sun sips at its hydrogen and will keep burning for 10 billion years or so, but the first stars gulped their fuel down. A star 100 times the mass of the sun might live only a few million years, a mere flicker by cosmic standards, a candle that flares brilliantly and then is gone almost as soon as it is lit. The first stars were not built to last. They were built to blaze. They lived fast. They shone with an intensity nothing had shone with before, and they died young. And in their deaths, as we shall see, they gave the universe a gift without which nothing else, not the later stars, not the planets, not the oceans, not the living things, not you, could ever have come to be. But before their deaths, in their brief and brilliant lives, the first stars began to change the universe simply by shining. And that change is one of the great turning points of all cosmic history, a slow lifting of the veil, a second dawn following the first, spreading outward across the darkness, one star, one region, one epoch at a time. Rest here a moment, in the light of that first star, before we follow what its light began to do. When we think of a star, we think of a single point of light, small and distant and self-contained. But a star does not keep its light to itself. Light travels, and the light of the first stars, especially their harsh ultraviolet radiation, went streaming out into the surrounding gas, and it began to work upon that gas, to transform it, to remake the very medium of the universe. To understand what happened, we have to remember the state the universe was in. Since recombination, since the fog first lifted, the hydrogen filling the cosmos had been neutral. That is, each hydrogen atom held on to its single electron, quietly, in the cold and the dark. The universe was an ocean of calm, neutral, unionized gas. But the ultraviolet light of the first stars was energetic enough to tear those electrons away again. When that harsh light struck a neutral hydrogen atom, it could knock the electron loose, splitting the atom back into a free proton and a free electron. This is called ionization. And so, around each of the first stars, a bubble began to grow. A bubble of ionized gas, a region where the harsh starlight had stripped the electrons from the hydrogen and changed its nature. Inside the bubble, the gas was hot and ionized and transparent to that light. Outside, in the darkness beyond, the gas remained neutral and cold, and as the star shone on, the bubble grew, pushing its edge outward into the surrounding dark. Now imagine this happening not in one place, but in many. As the Dark Ages ended and the first stars began to ignite, here and there, scattered across the vast young universe, each one lit its own small bubble of ionized gas around itself. At first, these bubbles were tiny islands of change in an ocean of neutral darkness, isolated, separated by immense gulfs of untouched cold gas. But the stars kept forming and kept shining, and their bubbles kept growing, and where two bubbles met, they merged and became one larger bubble, and that larger bubble merged with others still. Over hundreds of millions of years, the scattered islands of ionized gas spread and joined and overlapped, until at last they filled almost the whole of space, and the neutral darkness was pushed back into ever smaller and smaller pockets, and finally almost vanished. Astronomers call this great transformation the epoch of reionization, the age when the universe's hydrogen was ionized once again, this time not by the heat of the Big Bang, but by the light of the first stars and the first galaxies. It was, in a sense, the moment the universe truly woke. The cosmic dark ages had ended. The lights had come on, not all at once, but region by region, bubble by bubble, dawn spreading across the darkness, like the slow arrival of morning across a sleeping land. If you could have watched it unfold, sped up so that hundreds of millions of years passed in a heartbeat, you would have seen the black universe slowly fill with points of blue-white fire, and around each point a growing clearing, until the clearings joined and the whole vast structure blazed with the light of its first stars and its first infant galaxies. It is worth pausing on how gradual and how patient this all was, because it can be tempting to imagine the first stars switching on the universe like a lamp in a room, a single decisive moment. It was nothing so sudden. Reionization took hundreds of millions of years to complete, longer perhaps than the entire history of complex life on Earth. It was less a switch and more a tide, coming in slowly across a shore so wide that no single wave seemed to change anything. And yet, in the end, the whole shore was covered, and through all of it, the first stars were living and dying, generation upon generation, each one shining briefly and then giving way, each one adding its light and its gifts to the slowly brightening whole. But let us go back to a single first star, alone in its bubble, and think about what its life was truly like, because there is a loneliness to it that is worth feeling. Picture one of these population 3 giants, blazing blue-white in the black, 100 times the mass of our sun, brighter than millions of suns, and around it, nothing. No planets, almost certainly, because planets need heavier elements to form, the very elements that did not yet exist. No other stars nearby, for the first stars were scattered thinly across the young cosmos, each in its own dark matter halo, separated from its neighbors by distances so great that its light would take an age to cross them. No companions, no worlds, no one to see it. Only a single tremendous fire, burning in an ocean of cold hydrogen, briefly holding back the dark before its own end came. There is something almost unbearably solitary about that image, and yet there is beauty in it too, because that lonely, unwatched star, with no world to warm and no eye to admire it, was not burning for nothing. It was doing the essential work that would make everything else possible. It was building, in the crushing furnace of its core, the first heavy elements the universe had ever known. And when it died, It would scatter those elements into the dark, and they would drift and gather and become the raw material of a second generation, richer than the first. Every atom in your body heavier than hydrogen was forged in the heart of a star, and the very first such atoms, the seeds of all the rest, were forged in stars like this one, alone in the early dark. Let us follow that fire down to its ending, then, for it is in the ending that the gift is given. A star lives by fusing light elements into heavier ones, and by the energy that fusion releases. Our sun fuses hydrogen into helium, gently, at its core. But a star as massive as the first stars does not stop there. Its core is so hot and so crushed that once the hydrogen is exhausted, it moves on to fuse the helium into carbon, and then, in the largest stars, the carbon into oxygen, and the oxygen into heavier things still, neon and magnesium and silicon, each stage hotter and faster and more desperate than the last. In the final days of such a star, its core becomes a layered thing, like the rings of an onion, each layer fusing a different element, working its way steadily up the ladder of the elements toward iron. And at iron, the star meets a wall it cannot pass. For all the lighter elements, fusion releases energy, and that outflowing energy is what holds the star up against its own gravity, what keeps it from collapsing under its enormous weight. But iron is different. To fuse iron into anything heavier does not release energy, it absorbs it. And so when the core of a massive star becomes iron, the fire that has held it up for its whole life suddenly has nowhere left to go. The energy stops flowing outward, and gravity, that patient, endless force, which has been waiting all along, finally wins. In a fraction of a second, the iron core collapses. A structure larger than a planet falls inward upon itself almost instantly, crushed down by its own weight into something unimaginably dense. And the outer layers of the star, no longer held up, come crashing down after it, falling inward, faster and faster, until they slam into the collapsed core and rebound, and the whole thing detonates in the most violent event the universe knows, a supernova. In a single blast, the dying star pours out more energy than our sun will radiate in its entire 10 billion year lifetime. For a few weeks, that single exploding star can outshine an entire galaxy of 100 billion ordinary suns. It is a death, but it is the brightest thing there is. And in that death, two extraordinary things happen. The first is that the ferocious energy of the explosion forges, in an instant, the heaviest elements of all, the ones that even the star's long life could not make. In the searing crucible of the blast, atoms are slammed together and built up into gold, and silver, and uranium, and all the heavy metals that no gentle fusion could ever create. The second thing is that all of it, everything the star made across its life, and everything the explosion made in its death, all the carbon and oxygen and nitrogen and iron and gold, is thrown outward, blasted into the surrounding space, scattered across light years of the dark. The star does not keep its treasure. It gives it all away, in a single, blinding, generous act of destruction. This is the gift I spoke of. Before the first stars lived and died, the universe held only hydrogen and helium, the two simplest atoms, and a trace of lithium, and nothing more. There was no carbon for chemistry, no oxygen for water, no iron for planetary cores, no calcium for bones, no phosphorus for the code of life. The universe was, in a chemical sense, almost empty of possibility. And then the first stars forged those elements in their cores and in their deaths, and scattered them into the dark, seeding the pristine gas with the raw material of everything to come. The next clouds to collapse would form from gas that was no longer pure. It would carry a trace of carbon, a whisper of oxygen, a scattering of iron, and that changed everything. For one thing, that enriched gas could cool far more efficiently than the pristine gas ever could, because those heavier elements are so good at radiating heat away. And gas that cools well, fragments well. So the second generation of stars, forming from the ashes of the first, could break apart into many smaller pieces, and make not a few enormous solitary giants, but whole clusters of modest, ordinary suns, some large, most small, much like the stars that fill the sky tonight. The character of star formation itself was transformed by the death of the first stars. The universe went from making rare, lonely monsters to making rich, crowded families of stars, and it has gone on making them that way, more or less, ever since. And the heavy elements did more than change how stars formed. They made everything that is not a star possible. Around those later suns, the scattered heavy elements could gather into grains of dust, and the grains into rocks, and the rocks into worlds. Planets became possible only because the first stars had died and salted the universe with the elements that planets are made of. Every rocky world, every moon, every asteroid, every grain of sand on every beach that has ever existed anywhere is built from atoms that were forged inside stars and released in their deaths. And so is every living thing, the carbon in your cells, the oxygen you are breathing as you rest, the iron in your blood carrying that oxygen through you, the calcium holding you upright. All of it was made in stars, and the very first of it was made in the first stars, in the early dark, in bodies that lived only a few million years and then gave everything they had to the universe that came after. There is a phrase you may have heard, that we are made of star stuff, or that we are stardust. It is true, and it is not a metaphor. It is a plain description of where your atoms come from. But tonight we can say something more precise and more moving still. The lineage of your atoms reaches all the way back to those first lonely giants in the Dark Ages, the population 3 stars, the ones with no worlds and no witnesses, the ones that burned briefly at the very dawn of light and then died to seed the darkness. They are, in the most literal sense, among your most ancient ancestors. Their deaths made your life possible. Every time you take a breath, you are borrowing atoms that trace their history to the first fires the universe ever lit. Rest with that thought for a while, gently, without needing to do anything with it. That the calm rise and fall of your breathing tonight is connected by an unbroken thread of matter to a star that shone before the earth existed, before the sun existed, in a universe that had never known light. The first stars are gone. They died unimaginably long ago, but they are not truly absent. They are here, in you, in the very atoms that are resting now in the quiet of your body. Everything sealed has a reason, and the reason those first stars were sealed away in the deep past is that they had work to do there, work that would echo forward through 13 billion years and arrive, at last, at this moment, at you. There is more to the story than single stars, though, because the first stars did not remain scattered and solitary forever. Even as they lived and died, the same patient gravity that had gathered the gas to make them was still at work on a grander scale, drawing the small clumps together into larger ones, and the larger ones into larger still. The little dark matter halos that cradled the first stars were themselves being pulled toward one another, merging, combining, building up into greater structures. And as they merged, the stars and gas within them came together too, and slowly, over hundreds of millions of years, the first true galaxies began to assemble out of the darkness. These first galaxies were nothing like the grand spirals and stately ellipticals that fill the universe today. They were small, and ragged, and irregular, mere scraps and knots of stars, clumps of light gathering in the dark, far dimmer and far more chaotic than the great pinwheels we admire now. But they were the beginnings. They were the seeds of everything that would grow. Our own Milky Way, that vast river of 100 billion stars, whose faint band you can still see, arcing across a truly dark sky, began as one of these small, ragged gatherings in the early universe, and grew, over billions of years, by pulling in gas and swallowing smaller neighbors, building itself up, merger by merger, into the great structure it is today. Every galaxy has such a history. Every galaxy began small, in the dark, not long after the first stars, and grew by patience and by gravity into the majesty it wears now. And within these assembling galaxies, the deaths of the first stars left behind something else, something dark and strange and enduring, whose story reaches all the way to the hearts of galaxies today. For when the most massive of the first stars died, some of them, as we have said, may not have exploded outward at all, but collapsed inward, folding down under their own tremendous gravity into black holes, regions of space where matter is crushed so completely that not even light can escape. These first black holes, born from the first stars, were the seeds of something that would grow to almost unimaginable size. Because a black hole, once formed, can grow. It can draw in gas from around it and swallow it and grow heavier, and its greater weight lets it draw in more still. And in the crowded, gas-rich hearts of the early galaxies, these first black holes fed and grew and merged with one another when their galaxies merged and grew again over hundreds of millions and then billions of years into the tremendous objects we call supermassive black holes. Today, at the center of almost every large galaxy, including our own, there sits one of these giants, a black hole millions or even billions of times the mass of our sun, anchoring the galaxy around it, a dark and silent heart at the center of all that light. And the seeds of those hearts, the first small black holes from which they grew, may trace back to the deaths of the very first stars, in the early dark, at the dawn of everything. It is a strange and beautiful symmetry that the first light and the first darkness of this kind were born together, out of the same first stars. The blaze of a population 3 giant and the black hole that its death might leave behind. Light and shadow, arriving in the universe at the same moment, from the same source, and both of them going on to shape everything that followed. The light building the visible splendor of the galaxies, the darkness anchoring their hidden centers. The first stars gave the universe both its brightness and its depths, both the glow of the stars and the silent gravity at the core of things. And so the early universe, in the ages after the first stars, was a place of tremendous and rapid change, a great flowering out of the long dark ages. Astronomers sometimes call this era the cosmic dawn, and the busy age of star and galaxy formation that followed it, when the young universe was making new stars faster than at any time before or since, they sometimes call the cosmic noon, the high, bright midday of creation, when galaxies blazed with new stars and grew and merged in a great crescendo of light. All of it, the dawn and the rising and the noon, grew from those first quiet ignitions in the dark. The first stars were the small beginning from which the whole brilliant morning of the universe unfolded. Now, if the first stars are gone, if they died billions of years ago and cannot be visited, you might reasonably wonder how we can know anything about them at all. How can we speak so confidently of stars no human ever saw, in an age before the earth was formed, in a darkness sealed away by its own lightlessness? The answer is one of the most beautiful facts in all of science, and it turns the very slowness of light, which is a limit in so many ways, into a kind of gift. Because to look far out into space is to look back in time, and that single truth is the doorway through which we reach toward the first stars. Light travels quickly, faster than anything else there is, but it does not travel instantly. It takes time to cross a distance. The light from the sun, which is close to us as cosmic things go, takes about 8 minutes to reach the Earth. So when you feel the warmth of sunlight on your skin, you are feeling light that left the sun 8 minutes ago. You are, in a small way, looking 8 minutes into the past. The sun you see is the sun as it was, not as it is. And this only grows more dramatic the farther out you look. The light from the next nearest star takes years to reach us. The light from the far side of our own galaxy takes tens of thousands of years. The light from other galaxies takes millions, and from the most distant galaxies, billions. So when astronomers point a great telescope at a very distant galaxy and gather its ancient light, they are not seeing that galaxy as it is now. They are seeing it as it was when its light began its journey, billions of years ago. They are looking into the deep past, and if they look far enough, at objects distant enough, they can see the universe as it was when it was very young, when the first stars and the first galaxies were only just beginning to shine. The farther out we can see, the closer we can come to that first dawn. Distance, in the cosmos, is a kind of time machine. To reach the first stars, we do not need to travel. We need only to look far enough and gather light old enough and be patient enough to catch it. But this is easier to describe than to do, because the light of the first stars, if any of it still reaches us at all, has been traveling for more than 13 billion years, and it has grown faint, almost beyond measuring, and it has been transformed along the way by the very expansion of the universe. This last effect is important and worth understanding gently. The universe is expanding. Space itself is stretching, carrying the galaxies apart from one another, and it has been doing so since the beginning. And as light travels across this expanding space, the light itself is stretched. Its waves are drawn out longer, and for light, a longer wave means a redder color. Blue light stretched enough becomes red. Red light stretched further becomes infrared, the invisible warmth beyond red. And infrared, stretched further still, becomes microwaves and radio waves. This stretching is called redshift, and it means that the light of the first stars, which they poured out mostly as fierce blue-white and ultraviolet radiation, has been stretched so severely by 13 billion years of cosmic expansion that by the time it reaches us, it is no longer blue at all, no longer visible at all, but shifted far down into the infrared. And this is a large part of why the first stars are so difficult to study. To catch their light, you cannot simply use a telescope built for visible light. You need a telescope built to see the faint infrared glow that their once brilliant light has become. A telescope cold enough and sensitive enough and far enough from the Earth's own warmth and glare to detect a whisper of ancient starlight stretched almost to silence. This is precisely why, at the end of 2021, humanity launched into space one of the most ambitious instruments it has ever built, and sent it 1.5 million kilometers from the Earth, far beyond the Moon, to a quiet gravitational balance point where it could sit in the cold and the dark and watch. The James Webb Space Telescope. It was designed, above almost all else, to see in the infrared, to peer through the red-shifted haze of cosmic history and catch the light of the very first galaxies and, perhaps one day, the light of the first stars themselves. Its great golden mirror, unfolded in space like a flower, gathers the faint infrared glow of the early universe. Its instruments are chilled to within a whisker of absolute cold, so that their own warmth does not drown out the ancient signal they are trying to catch. It is a machine built, in essence, to look as far back toward the first dawn as our physics will allow. And in its first years, that telescope has already begun to change what we thought we knew. It has found galaxies far older and far more distant than many astronomers expected, galaxies that were already shining when the universe was only a few 100 million years old, in the very era when the first stars should have been living and dying. It has caught light that left its source when the cosmos was in its infancy, and in doing so, it has crept closer than any instrument before it to that first light. It has not yet, with certainty, seen an individual first star. That may be beyond even its reach, but it has pushed back the veil, glimpsing the early galaxies those first stars helped to build, reading in their faint light the chemistry and the conditions of the young universe, and testing, again and again, our patient theories of how the darkness first gave way to light. There is another way, too, that astronomers hope to reach the dark ages and the first stars, and it does not rely on seeing the stars themselves at all. It relies on listening, in a sense, to the hydrogen gas that filled the universe before and during the first dawn. This is a subtler and more difficult method, still being developed, still reaching for a signal so faint that catching it has proved enormously hard. But the idea behind it is elegant. Neutral hydrogen, the cold gas that filled the dark ages, gives off a very particular kind of radio signal, at a very particular wavelength, a soft whisper of radiation with a wavelength of about 21 centimeters, and as the first stars formed and began to shine, their light would have subtly changed the temperature and the state of that surrounding hydrogen. and those changes would have altered the faint 21-centimeter whisper coming from it. So, hidden within that ancient hydrogen signal, stretched by redshift like everything else from that era, there may be a record of the first star's arrival, not a picture of the stars, but a fingerprint of their influence, written across the gas of the whole young universe. Astronomers are building special radio instruments, some of them in the most remote and radio-quiet places on Earth, deserts and far islands, where the noise of human civilization is faintest, to try to catch this whisper from the dawn of time. It is painstaking work, hunting for a signal buried beneath 1,000 louder sources, and it has not yet given us a clear and certain answer. But it holds the promise of reaching into the dark ages themselves, into the very era we can least easily see, and hearing the first stars announce themselves in the trembling of the primordial gas. And there is a third way, perhaps the most poetic of all, which does not look outward into the distant past, but inward, at the ancient stars that still surround us here in our own galaxy. It is called stellar archaeology, and it rests on a simple and lovely idea. If the first stars enriched the gas of the universe with the first heavy elements, then the very next generation of stars to forming from gas that had been only slightly enriched, would carry only a tiny trace of those heavy elements, far less than younger stars like our Sun. And some of those very old, very metal-poor stars, if they were small enough and gentle enough, would have lived not for a few million years, but for billions, long enough to survive all the way to the present day. They would be walking fossils, ancient survivors, still shining in our galaxy after more than 13 billion years, carrying in their light the chemical signature of the universe as it was just after the first stars died. So astronomers search the oldest parts of our galaxy, its halo, and its most ancient regions, hunting for these rare and precious relics, the most metal-poor stars they can find. And when they find one, they read its light carefully, splitting it into a spectrum, measuring the faint fingerprints of every element it contains. And in the pattern of those elements, they can sometimes read, indirectly, the nature of the very first stars, the ones whose deaths enriched the gas from which these ancient survivors formed. The precise mixture of elements in an ancient star can tell you something about the mass and the death of the first-generation star that made them. It is like reading the ashes of a fire long gone cold and deducing from them the shape and size of the flame. We cannot see the first stars, but we can hold in our telescopes the children they left behind, and in those children read something true about the parents. Through all these methods, the great infrared telescopes reaching out into the deep past, the patient radio instruments listening for the whisper of the dark ages, the careful archaeology of the oldest surviving stars, we build our picture of the first stars piece by piece. It is a picture drawn not from a single photograph, but from 1,000 scattered clues, assembled with physics and patience and imagination, always incomplete, always being revised, always reaching further back toward that first light. And the picture it draws is the one we have followed tonight. Giant stars, born from pristine gas in the dark ages, blazing blue-white and brief, ending in brilliant deaths that seeded the universe with the elements of worlds and of life. That is the story the clues tell. That is the dawn we are slowly, carefully learning to see. And yet, for all our ingenuity, we must be honest about the limits of what we can reach, because those limits are part of tonight's story too, and there is a certain peace in acknowledging them. The plain truth is that we may never see an individual first star directly, with our own instruments, as a single point of light. There are reasons for this that no cleverness is likely to overcome, and they are worth understanding, because they return us to the theme with which we began, the theme of things sealed away. The first reason is distance and faintness. The first stars are so far away, in space and therefore in time, and their light has been stretched and dimmed so severely by the long journey, that even a single one of these tremendous giants, brighter than millions of suns, is reduced by the sheer scale of the cosmos to a signal fainter than almost anything we can detect. A first star shining alone in the dark ages is, from our vantage point, dimmer than the faintest thing our greatest telescopes can see. We can sometimes catch the light of whole early galaxies, the combined glow of many stars gathered together, but a single first star, standing alone, is very likely beyond our reach, its light spread too thin across too great a gulf. The second reason is time. The first stars were brief. A giant of 100 solar masses lived only a few million years before dying, and so at any given moment in the early universe, only a small number of first stars were actually shining. They were rare and scattered and short-lived, flickering on and off across hundreds of millions of years, like sparks that never all burned at once. To catch one, we would need to be looking at exactly the right tiny patch of the early universe, at exactly the right brief moment, and the odds against that are steep. It is not that they were unimportant, it is that they were transient, and the transient is always hardest to catch in the act. The third reason is the very darkness that surrounds them, the deep obscurity of the Dark Ages themselves. The era of the first stars sits behind the cosmic Dark Ages, in a stretch of history that gave off almost no light of its own, and what light there was has been stretched and buried and mingled with the glow of everything that came after. Reaching cleanly into that era, separating the signal of the first stars from all the noise between us and them, is a task at the very edge of possibility. It is like trying to hear a single soft voice that spoke once, long ago, at the far end of a vast and crowded hall, its echo now almost lost in the murmur of everything that has been said since. And so the first stars remain, in a real sense, sealed, not entirely hidden, for we have found their fingerprints in ancient survivors, and glimpsed the galaxies they helped to build, and reasoned our way carefully toward their nature, but sealed nonetheless, held behind barriers of distance and time, and darkness that may never fully lift. We may come to know them ever more richly, ever more confidently, through the clues they left behind. But to look upon one directly, to see with our own instruments the single blaze of the very first star that ever shone, may be a thing forever beyond us, a mystery that will keep its final privacy no matter how far we reach. Before we imagine our way back into that early universe, let us sit for a moment with one of its most striking qualities, one that is easy to overlook because it is an absence rather than a presence. The early universe was silent, not merely quiet, but silent in a way our world never is. Think of how rarely you have known true silence in your own life. Even in the stillest room, at the deepest hour of the night, there is something, the hum of the world, the faint sounds of your own body, the small noises of a house at rest. But the space between the stars carries no sound at all, because sound needs a medium thick enough to carry it, and the thin gas of the cosmos is far too sparse. And in the Dark Ages, before the first stars, there was nothing to make a sound in any case. No explosions yet, no collapses, no fire, only the vast, slow drift of cooling gas, gathering imperceptibly in the dark, in a silence so complete and so enormous that it has no equal in any experience we can have. And into that silence, the first stars did not so much make a sound as make an end to a kind of stillness. When the first star ignited, and later when the first supernova tore its parent star apart, these were, in the physics of the surrounding gas, tremendous events, sending shock waves rippling out through the thin medium, stirring it, heating it, setting it moving. The universe, having been still for so long, began at last to stir, not with sound as we would hear it, but with movement, with turbulence, with the slow churning that the first stars set going in the gas around them. The long stillness of the Dark Ages was broken, gently at first and then more and more, by the living, dying, stirring presence of the first stars. The universe began, in its own vast and silent way, to move. And let us follow, now, a single atom through all of this, because sometimes the whole immense story is easiest to feel when it is narrowed down to one small thing. Imagine a single atom of oxygen. Oxygen did not exist in the early universe. There was no oxygen at all until the first stars made it, fusing lighter atoms together in their cores. So picture this one atom of oxygen coming into being deep inside a first-generation star, forged in the crushing heat at its center. One tiny new thing in a universe that had never held its like before. It rests there, in the heart of the star, for the star's brief life. And then the star dies, and in the violence of that death, our single atom of oxygen is flung outward, cast into the surrounding dark at tremendous speed, set loose into the cold, thin gas of the young universe. And there it drifts. For a very long time, our atom of oxygen simply drifts, carried on the slow currents of the cooling gas, one among countless others scattered by the deaths of the first stars. Ages pass. The gas it travels in gathers, slowly, gravity drawing it down into a new cloud, and that cloud collapses, in time, to make new stars, and around one of those stars, a family of worlds condenses out of the leftover dust and gas, and our single atom of oxygen, after its long drifting, finds itself caught up in the making of a world. It becomes part of a rocky planet, bound into stone, or dissolved into a young ocean, or held in the air of a new and living sky. Billions of years pass. On that world, something stirs, and grows, and becomes alive, and eventually becomes aware. And one quiet night, a living creature on that world draws a slow breath, and among the atoms it draws in is our single atom of oxygen, forged in the first stars, scattered in the dark, and carried across 13 billion years to this one soft moment of breathing in the night. That atom, or one just like it, may be within you right now. This is not a poetic exaggeration. It is the plain and literal truth of where your substance comes from. The oxygen you are breathing as you rest, the oxygen your blood is carrying gently through you even now, was made in stars, and the very first of it was made in the very first stars, in the early dark. Every breath you take is a small reunion with the first light of the universe, a quiet meeting between your living body and the ancient fires that made the elements you are built from. You do not have to do anything to take part in this. You are already part of it. Simply by breathing, simply by being here, simply by being made of the things the first stars made. Let us leave the telescopes and the instruments for a while, and simply imagine. Let us do the one thing that costs nothing and reaches furthest, and place ourselves in the gentle theater of the mind, in that early universe, in the age of the first stars. It is a place no one can ever truly go, and so it belongs to the imagination as much as to science. And there is no harm in wandering there tonight, slowly, as you rest. Imagine, then, that you are drifting in the young universe, 100 million years or so after the beginning. All around you is darkness, but it is not empty darkness. It is full. It is a vast, thin, invisible ocean of hydrogen and helium gas, cold and quiet, drifting on the slow currents of gravity. You cannot see it, because there is no light to see it by. But it is everywhere, filling all the space around you, gathering imperceptibly into the great invisible valleys of the dark matter, flowing always, gently, toward the deep places. The whole universe here is a single held breath, waiting. Nothing has ever shone, nothing has ever burned. There is only the patient gathering of gas in the dark, and the endless soft pull of gravity, and time. And then, far off, so far that the distance has no meaning you could hold, a point of light appears, faint at first, a mere trembling in the black, then steadier, then brighter, and brighter still, until it blazes, blue, white, and fierce, the first star, igniting at the bottom of its invisible valley. And though it is unimaginably distant, its light, when at last it reaches you, is the first light that has ever fallen upon this part of the universe since the beginning. The darkness around you, which had been total, is now touched, faintly, by the glow of a single distant sun. And in that glow, for the first time, the thin gas becomes barely visible, a faint suggestion of structure in the dark, lit gently from far away by the first fire the universe ever made. You would not feel its warmth. It is far too distant for that. You would only see it, a lone, brilliant point in an ocean of black, with no world beneath it and no other star beside it, burning alone. And you might feel, watching it, something that is difficult to name, a kind of tenderness for it, perhaps. This solitary, doomed, magnificent thing, blazing with all its might in the emptiness, seen by no one, warming no one, and yet doing the quiet, essential work that will one day make watchers and worlds and warmth possible. It does not know it is the first. It does not know it is making history. It simply burns, because that is what it is. And it will burn for only a few million years, and then it will die, and give everything it has to the dark, and the universe will be a little less empty for its passing. And if you waited there, drifting in the imagined dark, you would see it happen again. Another point of light, in another direction, another first star, igniting in another valley, and another, slowly, over ages, the black would begin to fill with these scattered fires, each alone, each brief, each pouring its light and, in death, its gift of new elements into the surrounding gas, and around each one a faint bubble of change, the beginning of reionization, the slow clearing of the primordial fog. You would be watching the dawn of the universe, not a single sunrise, but a scattered, patient, million-year dawn, the lights coming on, one by one, across a darkness so vast that no single light seemed to change it, and yet, in the end, the darkness was filled. This is the scene that our physics and our patient reasoning paint for us, and though no eye ever saw it, it is as real as anything in the past is real. It happened. Those fires burned. That dawn came. And it came so long ago that the numbers describing it slip through the mind like water. Let us sit for a moment with the sheer depth of that time, gently, not to strain at it, but simply to let it wash over us, the way you might sit by the sea and let the size of it settle into you without trying to measure it. The first stars shone more than 13 billion years ago. To feel what that means, consider that our own sun and Earth are only about 4.5 billion years old. The universe was already more than 2/3 of its current age before the sun was even born. The first stars had lived and died, whole generations of them, and enriched the gas of the cosmos, and given rise to countless later stars and galaxies, all long before there was a sun to warm a young Earth, long before there was an Earth at all. When the first stars burned, the material that would one day become our solar system was still drifting, unformed, waiting for its turn, waiting for the gas to be enriched enough and gathered enough for a modest yellow star and its family of worlds to condense out of the dark. The first stars are not merely older than us, they are older than almost everything, older than the ground beneath you, older than the star that lights your days, ancient beyond the reach of ordinary imagination. And through all that immense stretch of time, an unbroken thread connects them to you. This is worth dwelling on, softly, as the kind of thought that can carry you gently down towards sleep. Because nothing in the universe happens in isolation, and the story of the first stars did not end with their deaths. It continued. Their scattered ashes gathered into new clouds. New stars formed, richer than the first, and they too lived and died and enriched the gas further. Generation followed generation, each one building on the last, each one adding a little more of the heavy elements, until, after billions of years and many cycles of birth and death, a particular cloud of well-enriched gas, in a quiet corner of a spiral galaxy, began to collapse, and from it formed a modest, steady, long-lived star, our sun. And around that sun, from the same enriched cloud, gathered the dust and rock that became the planets, and one of those planets was the Earth. And on that Earth, made of elements forged in generations of stars stretching all the way back to the first, something extraordinary eventually stirred. Chemistry became complexity. Complexity became life. Life became aware. And here you are, at the far end of that immense chain, resting in the quiet of the night, listening to a voice describe the fires that began it all, the atoms that make you. The carbon and oxygen and iron and calcium were not made on Earth. They were made in stars, and the very first of them were made in the first stars, in the dark ages, before there was anything at all to make them for. You are, quite literally, the descendant of that first light. You are what the darkness was preparing, in its long patience, all along. There is a particular kind of peace in that thought, and it is a peace worth carrying into sleep. It is the peace of belonging to something vast and old and gentle. The first stars were not separate from you, off in some distant, unrelated past. They were the first chapter of a story whose latest page is the rise and fall of your own breathing, right now, in the dark. When you feel small beneath the night sky, as everyone sometimes does, you might remember instead that you are not small in the way you think. You are old. You are made of the oldest things there are. The light that first broke the cosmic darkness is, in a real and unbroken way, the same light that eventually warmed the world you were born into. You are not a stranger to the universe. You are its child, and one of its very late and very fortunate ones, made from the gifts of stars that died before the earth was dreamed of. And perhaps this is the deepest reason the first stars matter, beyond the physics, beyond the elements, beyond the dawn they brought. They are a reminder of how much had to happen, patiently and in the dark, for this quiet, ordinary moment to exist at all, for you to be lying here, warm, breathing, safe enough to grow sleepy. An almost unbroken sequence of gatherings and ignitions and deaths and enrichments had to unfold across 13 billion years, beginning with a single star igniting in a darkness that had never known light. None of it was rushed. None of it was certain. It simply happened, one patient step after another, gravity gathering, stars igniting, stars dying, elements spreading, worlds forming, life stirring, until at last it arrived here, at this, the whole long labor of the cosmos, resting for a moment in the shape of you. For all that we have said tonight, for all the confidence with which the story flows, it is worth remembering how much about the first stars remains genuinely unknown, still argued over, still waiting to be settled. The picture we have drawn is our best understanding, built carefully from physics and observation, but it is a sketch, not a photograph, and there are corners of it still shrouded in their own darkness. And there is something restful, rather than troubling, in admitting this. Not every question needs an answer tonight. Some can simply be held, gently, as open and beautiful uncertainties. We do not know, for instance, exactly how massive the first stars truly were. Our models suggest they were giants, far larger than ordinary stars. But whether a typical first star held 10 times the sun's mass, or 100, or several hundred, is still debated. The pristine gas may not always have collapsed into a single enormous body. In some cases, it may have split, after all, into 2 or a few large stars, rather than one solitary giant. The details depend on subtle physics, on how exactly the gas cooled and swirled and fragmented in conditions we cannot reproduce and can only imagine through calculation. The first stars may have been more varied than a single portrait suggests, some truly monstrous, some merely very large, a whole hidden range of them scattered through the dark. We do not know precisely how they died either, in every case. The most massive of them may have met an even stranger end than the supernova we described. Some, in a particular range of enormous mass, may have been torn apart by a runaway instability in their cores, an event so complete that it left nothing behind at all, no dense remnant, no collapsed core, only an expanding cloud of newly forged elements and empty space where a star had been. Others, perhaps, collapsed so completely that they swallowed themselves whole, folding down into black holes without any brilliant explosion, dying in silence rather than in light, and perhaps seeding the universe with the first of the great black holes that lurk at the centers of galaxies today, including our own. The deaths of the first stars may have been as varied and as strange as their lives, and some of those deaths may be shaping the universe still, in ways we are only beginning to trace. We do not even know, with certainty, whether every first star was a doomed giant. It is possible, though thought to be unlikely, that some small fraction of the first generation were smaller, gentler stars, born somehow from the pristine gas despite all the difficulties. And if any such small first stars existed, they might, like other small stars, live for a very long time, tens of billions of years, longer than the present age of the universe, which raises a quiet and wonderful possibility. It means that somewhere, perhaps, in the oldest reaches of our galaxy or another, a true first star, a genuine population 3 star, made of the universe's original pristine gas, might still be shining, even now, an ancient survivor from the very dawn of light, overlooked among its countless younger neighbors. Astronomers have searched for such a star and have not found one, and most think none survive. But the search continues, and the possibility, however faint, is a lovely one to hold. A first light, still burning, hidden somewhere in the crowded sky, waiting to be recognized. These open questions are not failures of our knowledge. They are the living edge of it, the places where the story is still being written, where each new telescope and each new observation may bring some fresh piece of the picture into focus. In the years to come, the great infrared telescopes will look deeper still. New instruments, some not yet built, will listen more carefully for the whisper of the dark ages in the ancient hydrogen. Patient astronomers will continue to sift the oldest stars of our galaxy for the fingerprints of the first ones. And slowly, piece by piece, the portrait of the first stars will grow richer and more certain, even if the stars themselves remain forever, just beyond the reach of direct sight. The dawn will come more clearly into view, drawn not in a single stroke, but over generations, by many hands, each adding a little more light to our understanding of the first light of all. And so we arrive, gently, at the place where the science softens into something quieter, into the kind of reflection that these late hours are made for, because there is a lesson in the first stars that goes beyond physics, beyond elements and telescopes, and the mechanics of collapse and fire. It is a lesson about darkness and patience and the way that light comes into being. Consider that the universe was dark for a very long time before it was bright, that the first light did not appear at the very beginning, in a single triumphant flash, but had to be prepared, slowly, in the dark, over 100 million years and more of quiet gathering that no eye could have watched and no light could have shown. The Dark Ages were not a failure or a delay. They were the necessary work, the long, patient gathering without which no star could ever have formed. The darkness was doing something. It was pulling the gas together, deepening the wells, preparing the conditions, laying the ground for a dawn that could not have come any sooner. And when the first light finally arrived, it arrived because of everything the darkness had been quietly doing all along. There is a gentleness in that idea that is worth carrying with you. That darkness is not always emptiness. That the unlit stretches, in the universe and perhaps in a life, are not always barren. Sometimes they are the patient gathering before a dawn. Sometimes the quiet, unremarkable, invisible work of the dark hours is exactly what makes the coming light possible. The first stars teach us, if we let them, that light does not have to arrive all at once, and does not have to arrive early to arrive at last, and to be worth the waiting. And consider, too, the generosity that lies at the heart of this whole story. The first stars made the elements of worlds and of life, and they did not keep them. They gave everything away. A first star lived only a few million years, in solitude, unwatched, and then, in its death, it scattered every heavy atom it had forged out into the dark, holding nothing back, so that later stars and later worlds, and eventually living things, could be made from its gifts. The very existence of anything complex in the universe, anything that is not simply hydrogen and helium drifting in the void, rests upon that ancient generosity, that willingness of the first stars to burn briefly and then give all they had made to a future they would never see. They are the reason the universe is not empty. They are the reason there is chemistry and color and stone and water and breath. And they asked nothing in return, because they could not, because they were gone before their gift bore fruit. And perhaps, finally, there is something fitting in the fact that the first stars remain partly sealed from us partly beyond our sight, even now. Everything sealed has a reason, and the reason the first stars keep their final privacy may simply be that some things are meant to be known through their consequences rather than seen face to face. We cannot look directly upon the first star, but we can look upon everything it made. We can look at the galaxies it helped to build, at the elements it forged, at the worlds those elements became, at the life those worlds cradled, at our own hands in the dark, made of atoms that trace back to its fire. The first star is hidden, and yet it is everywhere. It is sealed away in the deep past, and yet its light, transformed and passed down through 13 billion years, is the light we are made of. To lose sight of it directly is not to lose it. It surrounds us. It is us. There is a way of thinking about exploration that treats every mystery as a problem to be solved, a lock to be broken, a darkness to be banished. And there is much good in that spirit. It has taught us almost everything we know. It has built the telescopes that reach toward the dawn, and the patient minds that read the ashes of ancient stars. But there is another way of holding a mystery, gentler and no less true, which is to let it remain a mystery, and to find in that remaining not frustration, but a kind of reverence. The first stars invite this second way. They allow us to come close, to reason and imagine and reach toward them, and then they hold, at the last, a quiet distance, a final veil we may never lift. And that is not a failure. It is a gift of its own. It leaves us always with somewhere further to reach, always with a little more darkness to wonder at, always with a dawn just beyond our seeing that keeps us looking upward. For the sky above you tonight, if you could step outside and look at it, is not the same sky the first stars knew. Their sky was black and empty and waiting. Yours is full. Every star you can see, every faint smudge of a distant galaxy, exists because the first stars lived and died and made the light-filled universe possible. When you look up on a clear night and feel the old, quiet awe that the stars have always stirred in us, you are feeling the far end of a story that began in total darkness, with a single point of blue-white fire, alone in the deep. The crowded, glittering sky is the inheritance the first stars left. They never saw a sky like ours. They made it, and then they were gone, and the sky remembers them in every point of light it holds. So let the story settle now, softly, as you drift. Let go of the numbers, the billions of years, the masses and the temperatures and the distances. You do not need to hold any of them. Let them dissolve, the way the primordial fog dissolved when the first light broke through. Keep only the shape of it, the gentle arc of it. A universe, dark for a long and patient age, a slow gathering in the deep, a first fire, kindled in the black, a dawn spreading, star by star, across the emptiness. A generation of giants, burning briefly and dying generously, seeding the darkness with the stuff of worlds. And then, across ages beyond counting, worlds and warmth and life, and at last a quiet night, and you, resting, made of that first light, at the far gentle end of the longest story there is. The first stars are gone. They shone before the earth, before the sun, before there was anyone at all to witness them, and they will never shine again, and we will very likely never see one directly, sealed as they are behind the darkness and the distance and the deep past. But they are not truly lost, and they are not truly absent, and they were never truly alone, because everything that came after is their continuation. Their light passed down and down and down, through star after star, world after world, life after life, until it arrives here, tonight, in the slow calm of your breathing and the quiet settling of your thoughts toward sleep. The first light that ever shone in the dark universe is still shining, in you, right now, in the dark. Rest now. Let your breathing slow and deepen, the way the young universe slowed and cooled and softened toward its first dawn. There is nothing left to reach for tonight, nothing left to solve. The gathering is done, the fire is lit. The long, patient work of the darkness has already, ages ago, become the light you are made of. You can let it carry you now, gently, the way gravity carried the first gas down into the deep, unhurried, certain, kind, down and down, into rest. Let the image of that first star stay with you as you drift, if it brings you peace. A single point of blue-white fire, far off in the black, burning quietly at the dawn of everything, asking nothing, making everything possible. It burned alone, so that one day, nothing would have to. It shone in a darkness that had never known light, so that one day you could rest, safe and warm, beneath a sky full of stars. It is the oldest light there is, and it is the light in your own atoms, and it is with you now, and it will be with you always, in the marrow of your bones, and the breath in your chest, and the slow, calm tide of your heart. Everything sealed has a reason, and the first stars were sealed away in the deep dark of the beginning for the oldest and gentlest reason of all, so that they could make the light, so that they could make the elements, so that they could make the worlds, so that they could, in the fullness of an unimaginable patience, make you, and having made you, they let the darkness fold gently back over them, content to be remembered not by sight, but by the simple fact of your being here, alive and warm, and drifting now toward sleep, carrying their first light quietly forward into another night. Sleep well, traveler of the deep past. The universe waited 13 billion years to arrive at this quiet moment, and it is in no hurry now. Neither are you. Let the first light hold you, let the darkness be gentle, and let yourself rest, as the whole long story of the stars rests within you, breathing softly in the dark. Thank you for spending this piece of the night with me, here at Sealed, where everything sealed has a reason, and every mystery is a place to rest, rather than a problem to solve. If this journey brought you any peace, you are welcome back any night you need a quiet place to drift. But there is nothing more to do now, and nowhere else to be. Only the soft dark and the first light within it, and your own slow breathing, carrying you down at last into sleep.